Hey guys, it's Mrs. Conway, and today we're going to talk about solving systems of equations where it's a word problem. So we're going to be taking a word problem, writing a system of equations, and then solving it. So I actually laid out some steps for doing that. So step one is to identify your variables. You're going to want to write in variables right here, and it is variables with an S. So make sure you're finding more than one variable, probably two. Step two, write your equations. Again, it's system of equations, so two equations. Now, then you need to solve your system. And I just want to make a note here of the three different methods you might use for solving a system. You could use graphing, you could use substitution, or you could use elimination. And I have showed you how to do all three of these types of solving. So you might want to refer back to old videos or old lessons or old notes if you forgot how to do some of those methods. And you only need to be able to do one of them to be able to solve a word problem. But it's good to have different ways to do it. And then this should be an obvious one. Once you've found your answer, you should write your answer in a complete sentence or two sentences. Okay. So let's just do one. Let's do an example. And then after I go over this example, I'll go over some more specific types of phrases you might see when you're writing, or just regular equations for that matter. So when I'm doing a system of equations word problem, I like to either highlight the important information, or if I'm doing it from a computer screen to a piece of paper, I'm going to be writing down the important information. So Gina and Matthew work at a dry cleaner's ironing shirts. Gina can iron 30 shirts per hour. So right here, I might make a note if I was doing this on a paper like you are, that Gina can iron 30 shirts. Well, actually, you guys have this worksheet, but if you didn't have the worksheet, you'd write down like Gina, 30 shirts per hour. Okay, and then Matthew can iron 10 shirts per hour. So again, you'd make a little note, Matthew, 10 shirts per hour. And then Gina and Matthew, oh, this is Gianna, oops, and Matthew worked a combined 11 hours and ironed 230 shirts. And then our question, which I like to use a different color for the question, is determine the number of hours Gina worked and the number of hours Matthew worked. Okay, so you guys have already practiced identifying variables a little bit, but you only had to pick. Now you have to actually write. And honestly, what I like to do is I like to come in here and I just go, okay, determine. All right, it's going to be the number of hours Gianna worked, and the number of hours Matthew worked. There we go. There's my two things. Let's use G for Gianna and M for Matthew. So G is the number of hours Gianna worked, and M is the number of hours Matthew worked. So now, whenever I want to talk about the number of hours Gianna worked, I can just use the letter G. I don't have to write that out every time. And same thing with Matthew and M. So right here, it says write two equations. Okay, so first equation, let's read. Gianna can iron 30 shirts per hour. Matthew can iron 10 shirts per hour. And they worked 11 hours and ironed 230 shirts. Looks like my first equation is going to be about shirts. So Gianna can do 30 shirts in an hour, so that's 30 G. And means plus in math usually. Matthew can do 10 shirts in an hour, so that's 10 M. And altogether they iron 230 shirts. I'm not using 11 in here because it's talking about hours, and this equation is about shirts. Okay, but now you're saying, Miss Conway, that leaves one number to make a whole equation. And I'm here to tell you that when you see the word combined, you should think of it as, like, whenever you see something like combined or total, you're just going to have, like, first variable plus second variable equals number. So combined means G plus M equals 11 hours. Because altogether, Gina and Matthew worked 11 hours. So they might have done some of those hours at the same time, but 11 hours were worked altogether. Okay, so now here's the step we haven't done before. I have to solve the system of equations. Now, there's more than one way that you could solve this system that would be correct. For instance, some of you might lean towards substitution because you would just have to move one of these variables to the other side, while some of you might lean towards combinations or elimination because your variables are already lined up. I'm going to go ahead and do elimination because my variables are already lined up. So my original equation is 30 plus 10m equals 230 plus m equals 11. Now the thing that I have to do before I can solve this, first of all, I'm going to think of this like 1g and 1m. That might help me. As it stands, if I added these together, nothing would cancel. So I need to multiply the second equation by a number that's going to make something cancel in the equations. So I'm going to multiply it by 10 because that number is smaller. So I'm going to cancel my m's. So I'm going to multiply the second equation between 10 and 30, 10 is smaller, by negative 10 so that my m's will cancel. So I'm going to multiply everything in the equation by negative 10. So I'll have negative 10g plus negative 10m equals negative 110. Now I'm not actually going to do anything to the first equation, but if it bugs you not to multiply it, you could say you're multiplying it by 1. So it's just going to stay 30g plus 10m. So now I'm on my adding step. So I now have a positive and a negative on the m, opposites. So I can just add my two equations together and it should make the m cancel out so I can figure out g. So I have 20g equals 120. 230 minus 110 is 120. Divide that by 20 is 6. So g is 6. Now, of course, that's not good enough. I need to also find m. Now, I'm going to just point out that when you have g plus m equals 11 as one of your equations, you should definitely use that one to find the other variable. So I know that 6 plus m equals 11. So I am going to solve that equation, which shouldn't take much work, to see that m is 5. Hopefully that's pretty obvious to most of you. But if not, here's what I did. I have 6 plus m is 11. If I subtract 6 on both sides to get m by itself, m would equal 5. Now, here's the only thing about a word problem. Normally, you would now put your answers in a coordinate point, which you can, but in this situation, since I'm not graphing it, I don't need to write my answer as a point. I need to write my answer as a sentence. So my sentence is going to be, G is 6, G was number of hours Gina worked, and M is the number of hours Matthew worked. So I'm going to come back to how I identified the variables and use those to form my sentences. So instead of saying G is the, I'm going to say Gianna worked 6 hours, and then M is the number of hours Matthew worked, so Matthew worked 5 hours. So Gianna, or however you say her name, worked hours. And then you could make a sentence there, a period, and do Matthew, or you can just make a compound sentence, and Matthew worked, and that's it. So there's how we solve a system of equations. It's a word problem. Now let's go over some common phrases you might see as part of word problems in general that can cause confusion. And so just how do we turn these into, equations? So the first one that you might see is there were 3 times, so I'm looking at times as many small boxes as large boxes. So for the purposes of this problem, I'm going to use S for small boxes and L for large boxes, okay? Whenever you have a problem like this, you want to first look what's bigger. So there were 3 times as many small boxes. That means small boxes is bigger. Okay, there's more small boxes. That means it's going to be S equals, and then that's where the 3 times comes in. 3 times L. So when you see something like this, you're going to get an equation that looks like this. So hopefully that'll help when you get those kind. Same thing with twice, except it would be 2 times. Here we have Charlotte sold 13 more pounds of bananas than pounds of raspberries. So for the purposes of this, I'm going to use B for bananas and R for raspberries. And the important thing here is when you see more, it means plus. And then again, think, which one's bigger? 13 more pounds of bananas. So bananas is bigger, so it goes on the left. Bananas equals 13 plus raspberries. And that's it. Okay, let's look at total or combined. Now we did a combined one in the other equation, but you also might see total. And so I did an example of total here. A combination meal with pizza rolls and mini hot dogs has a total of 21 pizza rolls and mini hot dogs all together. So that is something that's telling me if P stands for pizza rolls and H stands for mini hot dogs, then we're going to have P plus H equals 21. Because if you put them all together, there's 21 of them. If you threw them all on a plate and counted them up, there should be 21 altogether. So we're adding. Okay, lastly, this kind, normally you've got one equation that's like, you've got something like our first one here. So a lot of them you'll have number, letter equals something, and then one of the funny ones that I just went over, right? But sometimes you end up where you have 2 people and doing 2 different things. And I just wanted to go over one of these. In some ways they're easier, but if you haven't seen one, it might be confusing. So first of all, big hint, we have 2 people, Owen and Caden. They're going to do games and rides. Owen played 5 games and went on 6 rides and spent a total of $28.75. Caden played 4 games, went on 3 rides, and spent a total of $16.25. The question is, what is the cost of each game and the cost of each ride? So what I'm going to do, again, just for the purposes, normally I want you to be a little bit more, like write out your variables, but I'm going to use G for the cost of each game and R for the cost of each ride. So if Owen played, and so in this situation we have 2 people, you're basically going to have one equation for person 1 and another equation for person 2. So Owen played 5 games and went on 6 rides and spent a total of $28.75. So that's going to be, basically we have our Owen equation has 5G plus 6R is $28.75. So see if you can hit pause really quick and write Caden's equation. So hopefully you got 4G plus 3R equals 16.25. And then you would just proceed to solve that equation. Use a calculator to deal with the fraction decimals. And that's it. So if you have this little cheat sheet with you, you should be able to do some practice now of word problems. I'll help you out with the different types of word problems you might see. So go get your work done and good luck.